Welcome to LPKF here at Electronica. I'm joined by Florian Rock. Nice to see you again, Florian.
Yes, nice to meet you again, Trevor. Okay. It's been almost 1 year now, right?
Almost a year, yeah, that's right. It was Japan the last time.
Yeah.
So you're always coming out with new innovative products here at LPKF.
Right.
I want to talk today about the PicoLine 3000, which is your new laser system for depaneling.
Yes.
Laser is commonly referred to as laser ablation, but the problem with it has always been the burning and the speed. So let's talk a little bit about, first of all, the PicoLine 3000 and what's special about it.
Yeah, exactly. So the new PicoLine 3000 machine was specially designed for depaneling of assembled and not assembled PCB boards. So it's clearly in the industry of the EMS, electronic manufacturing services, and the what was until the issue right now in some cases was always that the laser still incorporated a little bit too much heat into the material. Right. And we especially addressed this issue with this new PicoLine 3000 machine by using a ultra short pulse laser. Now, the promise of the ultra-short pulse laser always has been to use less heat and to generate less heat inside the material during processing. And we made it also now possible, especially for FR4 depaneling. Okay. And the result you actually can see on the monitor, which is quite impressive.
So we're looking here at a result of comparing milling on the right side of the picture here. Exactly. with the laser system on the left. So you can clearly see from this picture on the right that the milling leaves almost a fairly rough exposing the glass.
Exactly, yes.
In the picture. But on the left it's a very smooth image that you see without any burn marks.
Yeah, and that's the new thing. We don't cause the epoxy to really carbonize.
Right.
And in addition to this, we can offer the advantage that you can see here, for example, on the right side with the mechanical milling, there's a lot of glass dust inside the material, inside the glass fibers. But with the laser now, you don't have any dust on the cutting area, and also no carbonization. So you can clearly see the raw material. You can clearly identify what are the what are the glass fibers and what is the epoxy material.
Right.
And yeah.
So what applications does this become important in?
It's really becoming very important for a lot of different applications. So the ultra short pulse laser is being put to use for cover layer cutting, for cutting of organic materials, because you don't want to have any heat effective zone, any discoloration. But then also for the FR4 depaneling, now it becomes really obvious that the laser depaneling is at the same level than the milling in terms of quality, if not even better in quality. And also from the speed point of view, we can also match the speed of the milling tool as well. If these were the only advantages of the laser depaneling would still have a very tough time to be utilized in much greater percentage than it's now.
Right.
So because we have the same quality, very comparable cutting speeds, but the laser also is adding or offering higher positional accuracy, for example. So you have no issues with fitting the PCB into a casing, which is very tight on the dimensions. What's also a big difference is the laser depaneling generates much less dust. So you don't have issues, especially with optical components on the boards, which otherwise need to be shielded, that particles from milling fall on the CMOS sensor, for example. It's not required by the laser, or when using a laser anymore. Another advantage is that we don't put physical pressure on the board. So you can very easily also use pressure-sensitive SMD components. And it's not even only these advantages. More and more is coming, and I barely can articulate this.
What about signal integrity or with RF devices, these types of things?
Yes, and that's very important when we talk about the coming fifth generation of telecommunication standards with incredible high frequency, up to 78 gigahertz or something like this, and the lack of carbonization assures that we have the same high frequency performance over the complete lifetime of the product. Mm-hmm. So also it's becoming very interesting for the automotive industry with the highest possible standards because of the safety. Right. That needs to be assured. What's also very interesting is that the laser depaneling requires much less space on the panel.
Right.
Which means
I see that from the example you have here.
Yeah.
You have a panel here that shows the pre-routing that you have to do.
Until now.
Until now. Yeah.
Until now, exactly.
Okay.
And
so then you compare that with maybe this one, for example,
yeah,
where you've got the same number of panels,
yeah,
but they're occupying much less space. So there's literally a 30% space saving as this shows using the laser system.
That's right. That's a very good advantage when we can compare the cost of using laser depaneling. During the last years, we had quite a dramatic increase in raw material cost for PCBs and for the FR4. Mm-hmm. So when you can save 30% of space, you also save the same amount of money.
Right.
And in addition to this, the pre-routing, the mechanical pre-routing is also not required anymore, which is also a process step which needs to be paid for. Right. But this is now becoming obsolete because you can very well utilize the laser also for a full contour laser routing. Right. And
so you can do radius bends and all sorts of different shapes and things.
One of the earliest advantages of using lasers, it's a digital process. You can very easily modify data, and you have no limitations regarding the geometry. Right. So there is no limitation on the shape of the PCB. Mm-hmm. Very important again when we talk about variables, for example. So there the system in package, for example, comes in very odd shapes, which is used, and the laser has absolutely no problem following these contours to provide the most degree of miniaturization.
Most accurate, yeah. Okay, and presumably you don't have the same consumable costs with drill bits and this type of thing.
Yeah, you are very, very knowledgeable about the laser, about the advantages of the laser. Yeah, obviously we don't use drill bits, so we are not in contact with the board. So we have the saving point of view here is that you don't have any wear and tear parts on the laser. And to make it even more easy for the customer to use, or for the EMS companies to use, a laser depaneling machine is that we can offer like up to 10 years of warranty extension. Okay. So the customer can easily choose to buy a warranty extension on an annual base. So you also know everything about your fixed cost. Right. So it's very predictable to use the laser.
So how does it really stack up in terms of cost versus a regular milling machine?
The cost of the laser the cost of the ultra short pulse laser has been very high for the recent years. So first we saw use, for example, in rapid prototyping or in universities, in not mass manufacturing areas, but as the lasers are becoming more and more useful tool, also the cost is being pushed down. Right. So it becomes now very reasonable to also invest into such an ultra short pulse laser.
So short pulse lasers, what you're saying is short pulse lasers are getting used in more and more applications, so they're making more of them and the price is coming down.
Yes, exactly. That's exactly my point, yes. Okay, thank you.
So it becomes really into a very viable option for people versus milling.
Definitely, yeah, that's true. And there's also a very great range of different lasers available, ultra short pulse lasers available, so they are not fixed to only like one wavelength, one pulse duration, one power level. No, it's not. So we have the option to select the right ultra short pulse laser to the material, because you always have to know how the laser interacts with the material, and you select the laser for the material. It's not the other way around, usually.
Well, Florian, it's great to see new products coming into the market. This looks like it's a real potential winner. So thank you for showing it to us today.
Yeah, Trevor, thank you very much, and of course Global SMT as well for the chance to introduce our new machine.